Hello everyone, welcome to Academic Coordinates. In this video we are tackling quadratic sequences. Now in quadratic sequences there exists a constant second difference between consecutive terms, right? And this is the general term for a quadratic sequence. Now before we can do any other thing here, I want us to prove that this is the case, because we said there is a constant second difference, So from this quadratic sequence general term, let's actually confirm that this actually has got a constant second difference. Now, the first term here will be a times 1 all squared plus b times 1 plus c. And what is that? That is a plus b plus c. What about the second term? The second term would be a times 2 squared plus b times 2 plus c. What is that? That is 4a plus 2b plus c. So the third term is going to be a multiplied by 3 all squared plus b multiplied by 3 plus c. This equals to 9a plus 3b plus c. And then the fourth term is going to equals to a times 4 all squared plus b times 4 plus c. This equals to 16a plus 4b plus c. Now let's actually confirm that this has got a constant second difference. So the first term is a plus b plus c, as we have shown here. And then the second term was 2a, sorry, it was actually 4a. It was 4a, this one right here, 4a plus 2b plus c. The third term was 9a plus 3b plus c. Then the last term was 16a plus 4b plus c, right? So let's find the first difference right here. So 4a plus 2b plus c minus a plus b plus c. So this is going to be 4a plus 2b plus c minus a plus b plus c, right? And then the answer to this is going to be 3a plus b, right? And then we're going to take this one again, 9, it's going to be 9a plus 3b plus c minus 4a plus 2b plus c. Then the answer to that, it's going to be 5a plus b, right? Then lastly now, let's take 16a plus 4b plus c minus 9a plus 3b plus c. The answer to that is going to be 7a plus b. So this is the first difference. So from the first difference, let's find another difference. 5a plus b minus 3a plus b. Then this one is going to be 7a plus b minus 5a plus b, right? So 5a minus 3a, that's going to be 2a, b minus b, that is 0. So our answer here is 2a, and then 7a minus 5a, that is 2a, b minus b, that's 0. So it's 2a. So with these guys, we have actually confirmed that a quadratic sequence has got a constant second difference. And we have confirmed it here. You know what I'm saying? That this constant difference here is 2a, and also here is actually 2a, Okay, I want us to do a question on an example. and do some practice here. Okay, so we've got minus 1, we've got 6, we've got 17, we've got 32, and 51. Then this continues. So let's find the first difference. So 6 minus 1. What is that? This is the same as 6 plus 1. So this equals to 7, right? What about 17 minus 6? So 17 minus 6, that equals to 11. Okay. What about 32 minus 17? Right? 32 minus 17, that is going to be 15. And lastly, 51 minus 32, that equals to 19. Okay, great. So now let's find the second difference here. 11 minus 7, that is, so 11 minus 7, that is 4, right? And then 15 minus 11, that is 4 as well. And then 19 minus 15, that is 4 as well. So now we have actually confirmed everything, you know? So we've got 4 as the second difference. So now let us find here the general term of this quadratic sequence. Remember, it's in this fashion. Tn is equal to an squared plus bn plus c, right? So now, from this, a plus b plus c equals to what? Let's go back from what we've solved. You see a plus b plus c where it was? This is a plus b plus c. So it corresponds to -1. So that is -1. So this will be your first equation, right? And then now, let's look. What else do we have? 3a plus b, right? The first term here is going to correspond to 7. You know, 3a plus b equals to 7. This is the second equation. And then last but not least, we have got 2a here. And then now 2a equals to what? It equals to the second difference, which is 4. So this is your third equation. So now let's start to solve. So from equation 3, 2a is equals to 4. So now if you divide by 2 on both sides, it's going to be a is equals to 2. Okay, so we got that. Let's find b now. So substitute a is equals to 2 in equation 2. So this is 3 times 2 plus b is equals to 7. So let's solve b here. Equals to 7 minus 6. So b is equals to 1. So we're going to substitute a is equals to 2 and b is equals to 1 in equation 1, right? So equation 1 is a plus b plus c is equals to, what is it? Is equals to -1. -1. So now our a is 2, yes. Sorry, we're going to solve for c here. So our a is 2 plus our b is 1 plus c is equals to -1. So this is going to be 3 plus c is equals to -1. So c is equals to -1 minus 3. C is equals to -4, right? So our Tn now is equals to a is 2, right? So it's going to be 2n squared. And then b is 1. It's going to be plus 1n. And then c is -4 minus 4. This is the general term of this specific quadratic sequence, right? If I can ask you, what is the let's say 16th term of this, then you're going to come here and say T16 is going to be 2 times 16 all squared plus 16 minus 4. Then you're going to find the value of T16. If I ask you, is term 50 in the sequence, then what you're going to do is that you are going to solve for n. In other words, the position that corresponds to a term, a supposed term that equals to 50. So it's going to be 50 is equals to 2n squared plus n minus 4. And then you solve for n here, and then you take the n that makes sense. And your n cannot be a decimal, right? Because we are speaking of a position. You know what I'm saying? Your n cannot be negative. We are speaking of a position. Okay, guys, a final recap. They are given by this general term or general formula or the nth term. And then we sort of utilize the general term to sort of find the first term, second term, third term, and fourth term in terms of A, B, and C. And then we actually confirmed that this will have a constant second difference, and which that was the case, which confirms that this is a quadratic sequence. And then we did this example, and then we equated everything, simultaneous equation. We found the general term of this quadratic sequence. And then if you are looking for a specific term, it's just going to be T16. In the place of n, you put the specific position that you are looking for, you know, and then you're going to find that. If you're being asked, is a term contained in the quadratic sequence? And then this is what you're going to do. You're going to put that in the place of Tn and solve for n. And remember, your n cannot be negative. It cannot be a whole number. It cannot be a decimal. So yes, because n is position. Do stay blessed, guys, and enjoy the rest of your day.